Hello, in this tutorial we are going to look at example and demos image segmentation with Ivy UNet, in which we're basically going to check how Ivy is implementing the UNet model for image segmentation. So I will open this notebook in Colab just because it is a bit easier to set up. We can test the functions a bit faster. So I will install Ivy and the required models. So in case you run this locally and you already have them installed, you can basically skip this step. So once the cell is loaded, we can then import Ivy Torch and NumPy into the notebook. So just waiting for that to load. Yes. And after this, we can look at some data preparation. So in any kind of machine learning pipeline, we need to do some data pre-processing before we pass it on to the models. So this is basically taken from the Torch implementation for pre-processing from UNet. So we are taking the width and the height of the object that we pass on, and then we scale it up and down based on the scale factor. Of course, we check it so that it's not zero or negative. And after that, depending if the object is a mask or it is an image, we do some processing on it. And then we return them as well. Then the following step after the data processing is basically loading the image. So it's a picture of a car we are going to see in a second. And then we are going to convert the image to Ivy as well. So here we can visualize the image. So let's see the image scaled as well. So this is the picture of a car. And after this, we are basically going to initialize the native Torch UNet. So what we can see here is the layers that currently exist in UNet, basically under the Torch implementation. So we can check what they contain, how they relate to each other. And the following step is very similar to that, but we are importing the UNet model from Ivy. So this is our implementation of UNet, and it's very important to set the pre-trained parameter to true, because otherwise the weights are going to be initialized randomly. So if you want to see the same results between the Torch model, basically, that we've just initialized, and the Ivy model, we need to set this pre-trained parameter to true. And the next step that I'm doing is basically compiling my model, and I'm passing on the image as a functional argument. So this is quite important to improve the efficiency of the model. In case you do not know what compile does, I would strongly suggest to go through previous videos and understand exactly how to use it, when and why. It is good to do that basically as a forward pass. So after that, we are going to do some custom masking for our image, our output actually. Again, it is taken from PyTorch. And it's fairly straightforward. We are just converting the mask to an image to have a format that we can visualize as well. So the first test, or the first resource that we are going to check, is basically test the Torch UNet model against our car image. And after that, we are applying some post-processing on the image as well. So here we can see the results. So this is basically the shape of the car that we've passed in the image. So we can see the contour for it. And we can run a similar process for Ivy as well. So, but now we are using the Ivy model with the same image, and then the post-processing is done using Ivy functions. And here is the result, which is basically identical to what we've seen from the original model from Torch. So the advantage of using Ivy instead of Torch is the fact that we can then take this image basically and use it in a different framework. So we can check this using TensorFlow. So the first thing that we are doing is import TensorFlow and set the backend to TensorFlow. Again, if you're not entirely sure why we need to set the backend to TensorFlow, please check the previous videos. And after that, we are loading the model again, converting it to a format that is compatible with TensorFlow, and then compiling the function, again, for efficiency purposes. And now we can run the same IV model, but this time we are basically using some TensorFlow post-processing methods as well on the image, and we get the same result. So inside the notebook, we have an example with JAX as well. So again, the first steps that we need to do are some initialization steps for JAX. And then we change the backend from TensorFlow to JAX. Again, just pass on the string of the framework that we need as an input. And then we initialize the model again from IV. After that, we apply similar steps to what we've seen before, but right now the image is a format that's compatible with JAX. And then apply some post-processing on the image. And once the cell is loaded, we are going to be able to see our result. This cell actually takes a bit faster to load compared to the TensorFlow one, just because we haven't compiled the model. So we can already see the advantage basically of doing a forward pass compilation instead of running the model basically without compilation. So again, very similar result to what we've seen before. So just at the end of the notebook, we can see the implementation of UNet basically in IV, and it's fairly straightforward. We have an initialization block, the building block as well that basically contains the architecture of the UNet, and then we have the forward block as well, the forward function, which defines how the layers interact with each other basically. And then below here, we have different variants from UNet depending on everyone preferences, basically which kind of model we want to apply. So thank you for watching the recording. I hope this was helpful, and yeah, happy coding.